standing by. For today's conference, all lines will be on listen only. I'd now like to turn the meeting over to Mr. David Hess. Thank you, sir. You may begin.
Thank you. Well, good morning, good afternoon, or good evening, depending on your geographic location. Thank you for joining us today. My name is David Hess, and I am the Business Development Manager for Sybase FSI in New York. We're very excited to have one of our strategic partners, Utopia, who is also an SAP partner and was named SAP Services Partner of the Year 2010 for North America. And they are here to join us for this presentation centered around how to improve business processes with trusted data. First, let me introduce our guest speakers. Frank Travis from Utopia has 22 years of experience in enterprise information management, solutions design, implementation, and consulting. At Utopia, Frank has multiple roles, including Director of Solution Management, and has written 2 recent white papers. The first, creating a data quality strategy, and the second, data migration management. He has delivered consulted services on a wide variety of EDLM, or Enterprise Data Lifecycle Management projects, from data governance through data quality to data migration. Frank has served as Vice President of EIM Strategy at Business Objects SAP, where he researched and formulated EIM and data quality market strategies. Our second speaker is David Dickman from Sybase. David is the Product Line Manager for Design Tools at Sybase. He manages the overall business for the modeling and metadata management line of products, including the overall vision and direction of Power Designer. David has over 20 years industry experience in both technical and business roles, working with small, startup, and established businesses. David has been published in industry magazines and is a regular speaker at industry events. Thank you, gentlemen, and what I'd like to do now is begin this presentation and hand it over to Frank Travis from Utopia. Frank?
To today's presentation, on how to build a data quality strategy and how to best move all of that information into a repository that we can actually store and save that and reference it in the future. When organizations go about handling a large-scale project, such as maybe a data migration, oftentimes they need to build a strategy on how they're going to cleanse and manipulate their information and standardize it and ensure that it conforms to their organization's needs. On our screen here, you can see, the fact that when you build out a strategy, you need to have your organizational goals clearly in focus. And I'll use a real-life case here as an example. I was working with a client in Manhattan, and it was a large global bank, and their goal was to increase their sales. That was their organizational goal. And they determined that in order to achieve that goal, they were going to improve their product cross-selling. And they targeted about $80 million in increased revenues through that product cross-selling and upselling across their customer line. Well, then they therefore determined that they needed to gain a single view of all of their customers across 270 different source systems and files so that they could actually do that cross-selling. So they progressed through a bit further, and as you can see, they started to build up a strategy. And they said, well, in order for us to gain a single view of all of our customers, we got to build a master customer information file. And then in order for us to build a master customer information file, we're going to have to match and consolidate all of our customers across all of those systems. And in order for us to match and consolidate those customers, we have to cleanse, standardize, match their names and addresses, and also have a clear idea of what products they've been sold, they've purchased, what are they currently licensed for, etc. So you can see that it all started out with the red-hand box there on the left, where you have your organization's goals. And that's important to keep in mind because they're going to drive your data quality strategy. Because inside of this project, to improve cross-selling, product cross-selling across the customer base, a data quality strategy was indeed formed because it formed the foundations for the success of this project. They had to have a data quality strategy in order for them to have a vision for the future and how they were going to achieve that goal. So that draws into light, the importance of having a data quality strategy. So as part of a data quality strategy, there are 5 aspects that we need to consider. The first is the subject area. And by the way, these 5 aspects form the framework to solve your strategy problem, because a lot of people look at, strategy, some of them are very handy at doing it, and some of them, don't have a clue as to where to begin. So this gives you that framework for kicking off your strategy process for solving this problem of how you're going to increase your product cross-selling and for gaining $80 million worth of revenue. So there's 5 areas or aspects that we need to consider when we build out a data quality strategy. First one is the subject area, and I'm going to talk about all 5 of these in detail, at least as time constraints here or permits. But the first one is subject area. This identifies, the type and usage of the data being cleansed. Is it financial data? Is it customer data? Is it manufacturing data? What kind of data? What kind of subject areas or domains are we dealing with? Then the second one is connectivity. Okay, once we know the data domains, how are we going to actually connect our data quality functionality to those source systems? Where are they? What kind of format is that data in? What are the technical issues that we need to cover for that? Third area is data flow. This maps how the data moves through the environment. And this is key for us because every data flow touch point represents an opportunity to cleanse data. And we will expose that a bit more. Fourth aspect is governance. The people and processes responsible for managing the data. Who owns the information? Who can make the decisions on what source systems should be involved? What are the permissions, the access rights? And when you get into the blueprinting phase of the project, who do you go to for the business rules governing each of those individual fields? How do they need to be transformed and adjusted and monitored? That falls under data governance. And then the 5th aspect that we need to consider as part of our strategy is data monitoring. Okay, it starts out with let's profile our data so we get an idea of how clean the data is today, right now, so that as we go through our project, we can see how we're improving the information, but also so we know what to cleanse, right? It's like going to the pharmacist and saying, I need medication, and they're going to ask for what disease or what illness. Well, you've got to find out what the illness is first, and data monitoring or data profiling will do that because all those data profiling tests you set up today to do your initial quality audit feed into monitoring over time, especially after you've deployed your project, so you can see how your quality trending is doing over time. And have you indeed affected the information? So what's interesting during all of this, all 5 aspects here, and as we prosecute them, is we're going to be doing a lot of pick and shovel work. We're going to be exploring information. We're going to be working through the organization. We're going to be, 270 different source systems. There's a lot of information just about those source systems and the people that use them and the business rules that govern them and how they connect and interrelate and what data is available and how current is it and how important are those individual systems. So during that evolution, that evolutionary progress through the program, we're going to be uncovering substantial amount of metadata. We're going to be mining that from our organization. It's going to be technical, business, and other. And we need to understand, how do we save that information so we can memorialize it? How do we share that information so that it's not lost, but also propagated to the other people in the firm? So that's a significant challenge, and it's a task that we need to uncover and manage during our project. What to do with all that information. So as we go through our data quality strategy, the first thing at a high level is we map the corporate goals to our data quality objectives, determine the subject areas, we identify the connectivity options, we diagram the data flows, we list the governance issues, and then we build our regression test cases from our data monitoring. Understand that there's program constraints we're going to have to deal with along the way. Time to market, resource availability, software costs, data volumes certainly, operational impacts. You can only muck around, forgive me for using that word, but get into the production systems during certain times of the day if you're going to extract the data for building a new source system. So all of these program constraints are important, and we need to be aware of these. And also, when we catalog them and they go into our strategy, we need to make sure we record all of these, and these can go into our strategy document, but they also, again, form, guess what, metadata around our project. So first factor let's talk about, or aspect we're going to talk about in detail here is subject area. This talks about, the types of data we're going to be looking at, which determines the necessary types of data cleansing functions. In other words, the data cleansing algorithms necessary for our project. So, just some examples: customer data, financial data, supply chain data, sales data. They're all different. They all will have data quality problems. They all will factor in to how to get that single view of the customer, because you need to know what product names they purchased, what were they code, when did they purchase them, what were the part numbers, so that you can accurately measure it or match them against the other product lines that you may have. What sort of financial data is involved? I mean, maybe some of your products that you're selling are financial instruments, so you need to worry about balances, account numbers, and certainly there's customer data. All of that forms richness around your metadata domain that we're going to need to keep track of as we go through and build out our program. So in this particular case, I've just selected 4: customer, SCM, supply chain management, that is, financial, and sales. So the next, feeding into that as part of that subject area factor is, you can see that, vice president up here, general manager, carpet cleaner. What's in the acceptable data domain? If you're a bank, is carpet cleaner a title that you should have? The message is that whatever functionality you use to cleanse your customer name and addresses, it has to have intrinsic knowledge, domain-specific knowledge about how to fix that information, how to test and validate that information. Same way with dates. The algorithm that tells you that cleanses and tests and validates, your closing date versus the first payment date, probably that algorithm isn't going to work for cleansing your names and titles. The same thing for part numbers. You're going to need a different algorithm for standardizing the part numbers and determining what is a valid part number or the range value. And the same thing with addresses. I mean, you have to have some pretty specific knowledge to know whether it's Cedar Haven with a space in the word or Cedar Haven all one word. So with that, you can see that we're drilling more into the information around the organization. We're below the domain area now, and we're down into the attributes for those individual entities and database tables. And so that information also needs to be captured and stored. So moving on, the next factor is the connectivity aspect. And this tells us, okay, once we know the data domain, we have an idea of the kind of functionality that we need, how are we going to connect that data quality algorithm to those source systems? Well, first of all, we need to know what source systems they are. We need to know, is our environment distributed across many regions or many different systems? So is it distributed or centralized? Is our data processing environment, is it homogeneous or heterogeneous? In other words, we've got spreadsheets here, we've got mainframe databases over there, we've got an Oracle application over here, and we have a number of third-party proprietary applications over there. That forms the richness of our complete data environment, and we need to get an idea of how that fits out, because remember, in this case, we got 270 source systems that we need to roll into one master customer information file. So this starts to build out the technical metadata that we have to deal with in our project. And of course, we need to store that somewhere. And as you might expect, not only does a system diagram help very much, but also a data flow diagram, because the connectivity aspect answers one question, and that is, how will we connect our functionality, our cleansing functionality to the data? But then the data flow aspect answers another question, and that is, when and where do we want to cleanse data? So as you can see here, this is another graphic taken from a real-life customer. It was a bank, and you can see that they had a number of operations here on the left side. Their website, account management, a loan origination system. They had branch offices, of course, and then they were purchasing third-party data. All of that fed into a customer reference file, where there's nightly loads into a data warehouse, and then from there it went down to a BI data mining tool for decision reporting, and then of course up to account roll-ups into universal involved parties. So what all of these avenues represent are opportunities to cleanse data, transactional updates, operational feeds, third party. And so when you build up your strategy, you need to determine against the program constraints that we talked about earlier, what do you have the time and resource and energy to do? I mean, maybe you've determined through your data monitoring or your upfront data profiling that your greatest problem right now is the information coming out of your loan origination systems, because you have critical errors there. And you determine, well, the biggest bang for the buck right now is to cleanse data right here at these transactional updates. Perfect. Strategy is, unfortunately, about weighing the pros and cons of different approaches and coming up with priorities and potentially compromises of when you're going to phase in what functionality. But the simple factor is, once you have the data flow outlined, you can make those decisions. If you don't have that data flow outlined, you can't make those decisions at least accurately. And so what this is doing for you is it's providing more metadata, specifically data lineage. Because if your CFO is given a report and he questions the validity of that report, through your data lineage, you can track all the way from your website account management, all the way through your information chain, down through the BI tool to the report that's presented, and tell them, well, this is how that report was generated. Again, important metadata, specifically data lineage, and also through that you can say what data we cleansed and when we cleansed it. So, again, it tells you how important that metadata is to the success of this particular Indy program that you want. The next aspect that we want to talk about is data governance. And, you can imagine if you have 270 different source systems, you've got a lot of different business units involved, a lot of different stakeholders. Who is going to make the decision as to what data should be extracted, what data is valuable, who has access, who has permissions to that information? That's all part of the data governance portion of the data quality strategy. To outline those stakeholders, the processes, so that you know who you can go to get the decision on, all right, what are the business rules around these account values? What subject matter experts should we engage? The data governance body will know who are the applicable subject matter experts, data stewards, if you will, to work on various aspects of the information. So what this does, though, is, data governance is driven and fueled by information. And so you can see here, you got business metrics up here, that's more information. You've got data standards and taxonomies, rules and definitions over here. You've got your decision rights, accountabilities, and control mechanisms. All of that feeds into information about not only the organization, but about our program and our project. And these are metadata attributes that we need to collect and store so that we can reference them later on and know who to talk to. Because while these three boxes feed information into the project, these two boxes right here, real-world business processes and data governance processes and systems, they extract information out. So they will consume the information that's provided. So the Data governance is all about, business and IT being synchronized and sharing information so that they're all in alignment. Well, what tools and technologies would be necessary? How should we organize the data? How do we interact with the business? A lot of these decisions and answers have to be memorialized and saved somewhere. What gets prioritized? How do we define the data? How can the data be used? This is a collaboration. Answers to these questions are arrived at through collaboration between business and IT, and those decisions and answers must be captured and stored so that the project can go forward. So last aspect I want to talk about is the data monitoring aspect. And this one, it started with initial data profiling of those 270 source systems and gave you the initial quality metrics of how complete the information is, how well it fit against your business rules. But it builds up over time because you're going to run tests periodically and you're going to want to post them on say, a data quality intranet site so that your consumers can see what is the quality of the information. So analysis of this aspect focuses on how to monitor data over time, before and after cleansing, what regular measurements are needed to collect and whom to report them to. It talks about providing periodic reports on the data quality indicators because we all know what gets measured gets done, and it quantifies the effectiveness of the data improvement action. What processes are actually creating or eliminating defects. And so the important thing here is it continually reinforces the end user confidence in the usability of the data. This is going to be key after you deploy your system. And so guess what? You will have, as an output of data monitoring, a tremendous amount of data quality information, metrics, metadata, completeness, consistency, conformity, duplication, the information on your transactional and master data relationships. This should be posted to an internet website, in my opinion, and it should be updated weekly so that people can see how the data in the system is progressing and improving over time. But first, in order for you to do that, you need a place, after you run your tests and your measurements and capture the data, you need a place to store the data, save it, organize it, and sort it, and determine what should be reported and when. And that takes a fairly sophisticated process and also a solution for that. And so with that, I'd like to turn the floor over to my counterpart on the presentation, David Dickman. David?
Thank you very much, Frank. And I think that this has been, so far, a very excellent presentation. What I'd like to show is a little bit about how we can use some metadata management technologies and metadata management tools to assist in what Frank has already told us so far. And before I begin, what I'd like to do is just quickly go over a little bit about what we've learned so far. And some of the lessons that Frank has given to us so far are, first, that the value chain of data is really this business mission critical capability. You've got to be able to handle the value of the data in order to best run your business, and the business demands it. The investment in these capabilities, in the ability to have quality data and the ability to provide that data in a way that's tied to business decision making, in a way that leverages that data for business value, that's the return on investment business is looking for and will be realized by having these capabilities that Frank has described. The other key element of this is it's necessary to connect key data to key business functions. The core idea here is, again, you can't boil the ocean. You can't get it all done in one pass. So you've got to look to and identify what is needed for what business criteria. This is tying to business goal and strategy, tying to business function, tying to business process. And those are going to be very key elements to be able to get the value chain of data up to mission-critical specs and capabilities. Frank also told us about the 5 aspects of the data environment. And these 5 aspects are subject area, ultimately defining the different types and usages of our classes of information, and not necessarily at a physical level, but understanding what is the kind of information we need, how does it fit with the business, and then where do we find it. And where we find it, of course, ties into the idea of connectivity as it relates to data quality. And the way I interpret this is it's not just finding the data in the right place, but also understanding its quality and integrity so that we can use the best sources in the best way for the best business value, which relates to the third value here, or the first aspect, which is data flow. And this is more than just mapping data movement at a physical level, knowing where it came from, where it went to, and how it got there, but also understanding the overall context of data as it's used by application and business functions. And to get all of that and understand it properly, the fourth aspect of governance is going to be key. People and processes and how they relate to all of this knowledge needed to be able to achieve the right key performance indicators on those first three aspects. And then last, of course, keeping it all running, getting that data monitoring, validating the data, and increasing the completeness, consistency, conformity, reducing duplication, and achieving master data relationships. So let's talk about how tools can help us with that. So there are several hurdles to overcome in achieving what Frank has talked about. Where the modeling and metadata management capabilities come into play are these particular hurdles. The first is, of course, there are multiple data domains. There's a lot of different data out there used by a lot of different businesses. A lot of different business units will look at each different piece of data for a different reason or use case. So identifying those domains in order to be able to focus the cleansing and quality efforts is going to be fairly difficult to do without some help. Also understanding that that data is going to be defined in multiple source systems. It's going to be stored and managed, and we need to find out where these things are, identify overlapping sources, identify multiple sources, and get the best summary of data over into decision support, get the best completeness of data over into master data, whatever it is that we're trying to do with bringing that multiple data source in to bring business value, in to bring better decision making. We're going to need to handle that. That's going to need some help. Also being able to provide consistent and reliable governance. We will have a lot of people involved, a lot of stakeholders. There'll be a lot of business rules to be involved here. We need to be able to define and describe those in such a way that we can consistently and reliably refer to them and assign them or bind them, if you will, to the various artifacts that we as individual stakeholders and contributors will be contributing to this system can realize and ensure that we maintain connectivity with. So we'll need help with that. And finally, synchronizing the business and IT communities. This is fundamentally about capturing who's doing what, where's it being done, when, how, and ultimately, to tie back up to business strategy, why. Why are these things being done? And so we need to map out ultimately what becomes the framework of an enterprise architecture, and we're going to need help with that. So tools like Power Designer are going to support us in these efforts because we have a few different aspects that we can bring to bear. So I've got a couple of them identified in this slide, but what I'll do is also go over to the tool and walk you through a few pieces of the product to show where we're going to be able to help take all of the things that Frank's talked about and all of the capabilities that he can bring into the tool to help give us the definitions and descriptions and ultimately the documentation that we need to be able to provide the value here. Things like conceptual data models, defining the core business domain. They'll capture ultimately the enterprise view of all those discrete domains. Independent of where this is stored in the database, independent of the kind of technology, whether it's a message, a physical database, application data, we don't care at this level because ultimately what we want to do is define the business domains and then tie them to one or more business use cases to make sure that we've defined the domains correctly. But then when it comes down to understanding the data mappings, not only can we map the various different physical structures together, we can also define the data movement and ultimately capture that lineage and heritage. What did the data mean? Where is it stored and where did it go? The conceptual models also help us standardize on semantics, and this is tying into governance. This is where we'll find the business rules and attach them to various different data artifacts as they ultimately become physicalized in our different data systems. And by the way, that sounds top-down, but it works top-down and bottom-up. We do a lot of what's called middle-out kind of support for metadata gathering so that existing systems can be well represented against standards that help us achieve a better business through governance iteratively, not evolutionary versus revolutionary, we say. And ultimately, we can do things like use the requirements model to capture business concepts and additional ideas like goals and strategies and things like that. But what I'd like to do is just quickly walk you through some of these elements in the tool. So here I have Power Designer. And the first thing we want to talk about quickly is this idea of the domains. So what I've got here is the conceptual data model showing various different domains and the content in those domains. So for example, in the sales domain, we had in Frank's presentation the idea that the sales domain included things like descriptions, part numbers, quantities, SKU codes, vendor data, all shown here. All of these different domains will represent the various different subsets of data elements, or in this case, data entities that are going to represent the constituents of that domain. And the one we fleshed out the most here for this example is the customer domain. So we can actually double-click to open the customer domain diagram, double-click to open the entity and look at additional details. And this provides us a richness of documentation around what are these various domains. Now, when it comes to the idea of validation, some of these domains are governed by sets of rules. For example, we have this idea of what are our part number ranges. So we have the definition here, but we also have this bound to the part number artifact so that we can find that traceability. We also have, for example, acceptable titles. This is was bound to the titles. We can actually do the binding now. So this attribute of titles, we have a certain set of valid titles. It's governed by a rule. There's the rule, acceptable titles. The definition of acceptable titles is here. And that has actually created a list of acceptable titles on the data element itself. And so this way we can have that tie back to some of the business rules and bind them and have the governance. Now the second aspect we're talking about is this idea of understanding how the applications and components and systems fit into this. Well, for that, I'd like to look at a different diagram. And this is also from Frank's presentation. Represented in Power Designer, we have an architecture diagram to help us understand what different systems and applications and databases are all going to be part of the ultimate flow for our project here. And, for example, things like this data warehouse, these are actually ultimately represented by physical data models. This data warehouse model is actually found in our model set here. Oops, wrong button. And so, for example, we can go and open the diagram, and there's our data warehouse model. Now, this leads into the idea of managing the flows. So one of the ways that we can talk about managing flows is, of course, at this physical level. Here we have the data warehouse model, and the data warehouse model has the mapping editor that allows me to say, well, where is the data in the source systems, one or more? So we have the ALCAN, the CDI repository, operational data store. These are all coming from that architectural model as well. And we see how they're mapping in some ways simple and in some ways complex ways to the various objects that are going to be in our data warehouse. This is great because this is giving us that kind of data lineage. Where did it come from? How did it get here? What process did it follow? But it lacks a little bit of detail. So for additional detail, we also have another model that we use called the data movement model. And the data movement model basically allows us to define the various stages along the way in any kind of flow from sources to warehouses. I have a very simple representation of that. But as you can see, we're able to handle various different joins, projections, filters, sorts, everything that you would find in a typical ETL environment, merges, calculators. And the whole point of this is this gives us this roadmap from the individual source elements and how they transform into the target. And this allows us to capture the flows at the physical level. But there's also another concept of flow, and that's the concept of tying into the business flow. Ultimately, what we're talking about now is really the alignment between the business process, the capabilities the business performs, and the various data constituents that are participating with it. So for that, we'll look at a business process model. Again, adapted from Frank's presentation, we had this idea of flow with a series of processes on some data. So transactional processing here handles customer loans into the main feed processing, which then feeds maintenance for data migration and operational feed. So this is the flow of control. What's really interesting is this customer loan, or customer and loan data, is really a customer data element and a loan data element. And again, to give us that kind of governance, that kind of traceability, that single source of truth around metadata, especially at these architectural levels, a tool like Power Designer really provides value. So here I see the customer is actually defined as an entity with attributes in this diagram. And we're back to that main diagram. By the way, this object itself has been generated out to a physical representation. And so we also have not just traceability to where this thing has been used, and we can actually remove some of these details. We want to include the data and flow details. And we don't need the attribute details. So we see it's generated out to a table with a set of physical characteristics. It participates in a business flow, and this shows us a different kind of heritage and lineage. This is the data concept, where it's implemented, and what business concept it represents. And from here, we can actually go one step further and show the impact analysis diagram. And this tells me if I need to make a change to a business concept, where is this going to be impacted in source and warehouse and master data systems and data transformations, business processes and business goals. And this allows me to keep everything in lockstep with the ongoing transformation in the business. So these are where, and this is just high level, drive us down to physical implementations, drive us down to process and application and technology viewpoints. And this gives us the ability to manage the information needed at a metadata level and an architecture level to be able to give us that completeness, consistency, and conformity we're looking for, to remove that duplication, and ultimately define, because we have that enterprise conceptual view of business process and business data, those master data relationships, define and describe them before they become physicalized in systems. So back into the slides here. Ultimately, what we're talking about is Power Designer's unique link and sync technology. It's not enough just to define and describe the various lists of things that we have, but it's tying all of those things together at a level of granularity and a level of intimacy that makes things like impact analysis and gap analysis function for us. It gives it that tie to the business and the business concept without losing sight of the ultimate implementation and how the quality and integrity of that data is physicalized in our existing systems. What link and sync technology does is it removes those metadata silos. It allows you to increase that alignment between the business views and the technology views, and that ultimately provides the reduction of time, cost, and risk associated with change. And Gartner's telling us that this is going to become more critical as well. What Gartner's basically telling us is more and more as we look at architectural initiatives, they're going to be driven more and more by business function and business value. Demonstrating business value by communicating the language of business is going to be where 70% of our architectural initiatives will be spent by next year. And by the year after, 30% of the core IT teams or core enterprise architecture teams are going to be focused away from the pure technology architecture and more towards business architecture. And that's why, again, capturing these core essence definitions and descriptions in an integrated way with IT is going to continue to allow us to keep IT relevant and keep IT invested and keep IT representing business value. So what you can do next for Power Designer is schedule a customized demo. I showed you a few things, but perhaps there's different concepts and problems that you're trying to solve in your enterprise. Best thing to do is let us know specifically what you need to see, and we can help with the customized demonstration. Lunch and Learn is a good way to do this. We do this with a lot of our customers. Best way to reach Sybase for this is to call 1-800-8-SYBASE and press 1 for the sales option, and let the folks know you want to schedule that customized demo. And if you're outside North America, Sybase's website has all your local sales office contacts. Feel free to talk to them then. There's also some additional information that we can provide to you. There's white papers on data governance from a fellow by the name of David Lotion. We also have this white paper by Frank Dravis on the Utopia website, Creating a Data Quality Strategy. Excellent white paper and goes deeper into the concepts that Frank talked about earlier in this session. You can evaluate Power Designer with the Power Designer download. Click the download trial off the Power Designer webpage shown here, and it'll give you a full product that you can play with. And if you need additional time, certainly feel free to contact sales for additional trial agreements. Also feel free to contact Utopia. Utopia can be found at their website, www.utopiainc.com. There's Frank Dravis's email here, and for general inquiries, info@utopiainc.com, or call the 1-847-388-3600 phone number shown here in the slide. Also, don't hesitate to ever contact Sybase. Feel free also to contact David Hess, who's been our gracious moderator today, and he'd be happy to help you with any additional questions you have about both Sybase, Utopia, and how we're working together to bring you a whole solution around improving the data quality through strategic means. And So thank you. At this time, I'd like to open us up for Q&A.
Thank you, David. Just to mention, if you have a question, there is a pull-down window at the top of your interface. It's Q&A. If you have any questions, feel free to type them in there, and we'll answer them as they come in. Also, at the bottom of your screen, you'll see a little printer icon where we'll give you the ability to print this presentation in a PDF format. So feel free to do that as well. We do have a question here. Question is, what is your operational definition for data standards versus business rules? And I believe this was directed to Frank.
Thanks, David. So what is, well, I think I understand the question, but can you state it again for me, please?
Yes. What is your operational definition for data standards versus business rules?
Okay. So data standard, you can say that one is a subset of the other. Data standards are indeed specialized business rules. So data standards can either be very large or very tactical, very specific. For example, what is a specific formatting of a given field, column of information, etc. Business rules can cover a wide range of things, cross-table, cross-column calculations, when data should be used. So in essence, data standards are indeed business rules, but they're very specific type of business rules. And your business rules in general can cover a wide range of things. For example, subject matter experts. Who should I get involved with when? That could be construed to be a business rule. Back to you, David.
Okay. Next question. How beneficial such as data warehouse model would be applicable for fraud risk platform using TXN exception monitoring?
I think that question should go to David Hess, or David Hickman, sorry.
David Hickman, yeah. Did you get that question, David?
Actually, if you could state again, there was a few different details there, and I'm not sure.
Saying how beneficial such kind of data warehouse model would be applicable for fraud risk platform using TXN, capital T, small xn, exception monitoring.
So I think the best way to answer that question is actually take a step back and come at it a little bit more conceptually. Ultimately, what we're talking about is, would the data warehouse model be beneficial when working with any kind of transaction exception monitoring or other methodology for fraud and risk detection? The ultimate answer to that is the model is ultimately the blueprint of what's going to make a good system. The model itself is, of course, going to be very beneficial because the model is going to define and describe what it is, where it came from, how it's there, and what's going on. Ultimately, the structure of the model, the choices made in how that model is formed, and the kind of information that's streaming into the warehouse and the kind of analytics performed on the warehouse are going to make the difference in whether the fraud and risk detection system is going to be operating correctly. So again, from an architecture perspective and a tools perspective, having the right knowledge base to build these systems and maintaining and managing that knowledge base, knowing the quality of the sources, knowing the integrity of the transformations, knowing the structure of the reports and how they all tie into the various business rules you have around what makes something determined to be fraud, what makes something determined to be high or low risk, are going to make a better system.
Okay, thank you. Next question. In the business flow diagram, are the data flows represented as simply sets of data elements, attributes, or structures similar to SQL views against the enterprise logical data model?
I'll give my first answer for that, and then I think David Dickman should follow up on this. The answer for data flows is that you got to have multiple levels, all the way from the highest level source system down to the lowest level functional operation. And it's all determined by how and when you need to drill down to make a critical decision on the data quality element that needs to be cleansed. So having said that, I think that we can also present an answer for this question in terms of power design. David?
Absolutely. Thank you, Frank. Frank's absolutely right. The idea is that there are multiple different levels of data flows and multiple different models that represent those different levels. The various different levels of abstraction, the conceptual, contextual versus the logical, physical, are all different representations, and Power Designer supports all of those. So ultimately, the answer to the question is yes to all of this. In an analytics contextual level, the data flows would want to be simply the core sets of data elements or attributes. However, when we get to a more operational business flow diagram or data flow diagram that represents something perhaps more automated or more systematic, then it would tie to logical representations. And ultimately, in the process orchestration models and the service orchestration models, to physical representations of actual data in actual systems. And all of these layers of abstraction can be rolled together so you get that drill up and drill down, so you can look at it contextually and say that and that, I need to look here, open things up further, look at further detail, and ultimately find an individual transaction or an individual physical artifact or an individual table or view, whatever level of granularity you need to get to be able to identify, is this a place where I need to spend my effort? Is this the thing that needs to get fixed to solve a problem that we've identified in the ultimate result for the business?
Okay, very good. Well, that seems like all the questions that we have right now. Just information on the follow-up here. We'll be sending out a link for this live broadcast recording, so you can show it to your colleagues or take a look at it again. And as David had mentioned, feel free to contact Utopia or Sybase. We'd love to come in and take this to the next level where we can get into a little bit more about your business and how you could use this technology and the types of solutions that both Utopia and Sybase have to offer around enterprise information management and metadata management. Thank you, everyone, and look forward to seeing you in the future. Thank you.